So today we have Dr. Phil Legg from the University of the West of England. So he's an associate professor and a lecturer in cybersecurity there. So first of all, I want to start with congratulations, because the University of the West of England has been recognized as an academic center of excellence in cybersecurity education, which is a very prestigious recognition, and they were recognized in the first round, so that's absolutely amazing. Phil is also a co-founder of CCUK, which is a colloquium for Information System Security Education, and that's actually how I've met Phil on one of the events organized by CCUK. So he's one of the co-founders. So today we have a session about light bulbs and race cars and the use of cyber-physical systems for cybersecurity education. So I'll pass it over to you now, Phil.
Okay, thank you very much for that introduction, Julia. Really appreciate it. So hello, everyone. I'm Dr. Phil Legg, Associate Professor in Cybersecurity at the University of the West of England. And I'll talk about light bulbs and race cars and cybersecurity education using cyber-physical systems. Okay, so you've already heard a little bit about me. I'm the program leader for the NCSC certified MSc in cybersecurity, and I'm also the co-director of our UE Cyber ACE CSE. My research interests stem around cybersecurity, machine learning and visualization. Some of you will know me because I actually am alumni of Cardiff. So I did my undergraduate and my PhD in Cardiff with Professor Paul Rosen and Professor David Marshall. So there I was looking at computer vision and machine learning applications. I then moved to Swansea for a postdoc role, which is how I know Parisa originally. And that was working on data visualization work. And then after that, I moved to a postdoc role in Oxford, working on cybersecurity and insider threat detection. And that was really bringing together the background in machine learning, the background in visualization, to actually understand, how do we use machine learning for the purpose of cybersecurity and the purpose of understanding user behaviors, and then how do we use visualization for actually interpreting that information, whether we're thinking about explainable machine learning models, whether we're thinking about how an analyst actually takes action and reacts to information that they're identifying. And so it really, a lot of my interest is around how we use machine learning and visualization for the purpose of improving cybersecurity. Okay, so just very briefly to talk about a couple of projects that I'm involved with stemming on from this. So I'm involved in a project called CAV4, which is all around connected autonomous vehicles. In particular, this is looking at a connected autonomous bus that would run across the Forth Road Bridge up in Edinburgh. So how could we develop a connected autonomous bus that is able to ferry people from Fife over into Edinburgh city centre? And what are the cybersecurity implications of this when we're thinking about vehicle to vehicle, vehicle to infrastructure, vehicle to X communications? There's another project I'm involved in on called the Umbrella Network, which is something that's been set up by South Gloucestershire Council and Toshiba. And essentially, this is a 5-mile stretch of industrial IoT nodes that we're then looking at being used for all different purposes, from weather monitoring, from smart manufacturing, all the way through to connected autonomous vehicles again. And this connects UE to the Bristol and Bath Science Park. And so there's a lot of link up there around what kind of projects could we do, given that we've got this heavily connected infrastructure running between these two sites. There's the Scout project, which is in collaboration with Business and Law and Avon and Somerset Police Synologic, which is looking at how we identify cybercrime behaviors and dark web activities, in particular thinking about cryptocurrencies and blockchain activity. And then there's finally some work we've done with Monvia and TechModal, so two regional SMEs, looking at explainable models for understanding artificial intelligence models, and also thinking about the explainability bit, but then how does explainability feed into adversarial attacks on machine learning. So if I can explain the model, can I then understand the weaknesses in that model? And how do I then use that explainable ML to then defend that ML? Okay, so that hopefully gives you a little bit of a taste of some of the research projects I'm involved in at UWE. But today, we're going to be talking about my other hat. I mean, as academics, we all wear many different hats. And in particular, I wanted to talk today about cybersecurity education. So as Yulia very kindly said, we are recognised by the National Cybersecurity Centre as an academic centre of excellence in cybersecurity education. So we're very pleased about this. And we do a lot of work with schools outreach through our Unlock Cyber project. And that's been running for maybe 4 or 5 years now. And I'm also a co-founder, along with colleagues from Abertay, from Kingston, and from the NCSE, of CISI UK. Okay, so CISI UK is all about how do we promote greater collaboration and sharing among HE, as well as with industry, with government, with other education providers, so that, you know, as a nation, we can essentially improve the state of cybersecurity. And this, you know, this really stemmed from the work that happens in the US with CISI, which has been running for 24 years now, something like that, where they make a real focus on the pipeline, and they talk a lot of K through 12, okay, so kindergarten all the way through to 12th grade. And they really do, you know, try and set out that kind of plan of how are they supporting cybersecurity education all the way through. And that's something that I'm really passionate about, because, you know, for too long, I feel like it's been treated as, you know, they come to university and then we'll start talking about cybersecurity. And like, we need to be mindful that, you know, there's a lot of discussions that happen around that topic in schools, and some schools are doing lots on that, some schools are not doing as much. But nevertheless, you know, they're not, this isn't something they're coming to us fresh about, because, you know, they're involved with technology in their lives. You know, cybersecurity plays such a role into how they're making use of technology. I mean, you've only got to look at the last year to understand that. And so this is really trying to join up the dots so that we know what's been happening in schools, so that we can make the best of HE education when they come to us. And then obviously we can carry that pipeline through when they go into industry and lifelong learning. Okay, so there we are. Okay, so I wanted to talk a little bit about cybersecurity education and thinking about that outreach piece. And so we've been doing outreach for, you know, a number of years in various different ways. We have a scheme called BoxEd that the university runs. But in terms of cybersecurity, in the last few years, we've been getting more and more involved with the likes of the CyberFirst scheme, running CyberFirst events. But we're really saying, you know, how do we get our students more involved in this? You know, it's all well and good us saying, oh, we'll host a CyberFirst competition on site or what have you, and people come in and they do that. But we wanted to create opportunities for our students to get involved in running these kind of activities. And then it's the question of, well, how do we make it interesting and engaging for all age ranges, you know, really as a way of enticing them into this field of study. So back in November 2019, which now feels like a very, very long time ago, we were involved in an event hosted by the NCSE called Empower Cyber. And that was 800 girls all attending for a one-day workshop hosted in Gloucestershire. And we had students there running our Severo workshop. So Severos, I haven't got one to hand, unfortunately. Severos are basically a little ball, a little robot, okay? And you can have an iPad app, iPhone app, to basically control that robot, to make it move around in whichever way you want. And there's also Python libraries and the like, which you can get to communicate with this thing, because essentially it runs on BLE, so Bluetooth. So we had this activity running where students could essentially get a Sphero, they could control it using the iPad app, okay, and can they make it navigate around a course? And it's quite nice because it links up with kind of visual programming languages like Scratch and the like, where you can essentially drag and drop those blocks on to be able to say, right, drag in a for loop, drag in, walk 1 meter forward, and you can make it do different processes. But then, as I say, there's also Python APIs to be able to interact with this kind of stuff. So we had this workshop where essentially we had one student trying to control a Sphero, and then we said, right, okay, have a laptop, see whether you can make it also do something else, and actually, can you cause it to crash? And it's starting to get them thinking about, what happens when there is an adversary on my network trying to attack me or trying to make my device do something that's unexpected. Okay, so that was where we started back in November 2019 with these kind of things. And then January 2020, we were running a workshop on scale electrics. Okay, so again, this was in support with the NCSE Cyber First program. And what this was a scale electrics track, which obviously students had to build the track and everything, but then we'd set the track up with sensors. Okay, so there's a little sensor, motion sensor, being able to recognize essentially when the light intensity changes as the car passes it. Okay, and so we were able to use that sensor as a lap sensor. That's rigged up to a Raspberry Pi using the GPIO pins on the Raspberry Pi. And the Raspberry Pi essentially serves as a lap counter. Okay, so on the picture here, you can see a bunch of students gathered around setting up the scale electrics and the like. And we've got this Pi connected to a screen, just displaying this lap counter here. Okay. And that's all well and good, and the students really enjoy racing these cars around, playing scale electrics as you would do. And then we've got a laptop again. Okay, so the laptop's over here in this picture, and we've got students using Kali Linux. Okay, they're using Kali Linux, being able to try running things like Nmap and try running things like Hydra. Okay, and starting to just get them exposed a little bit more to these kind of tools which are being used in cybersecurity nowadays. Okay, so they can run Nmap and they can see what devices are on the network they're connected to. So we've got our own local network which the Pi is connected to, and they can find the Pi. They can see that port 80 is open on it so that they can try and access a web server. And then we've got a worksheet which essentially allows them to step through to say, okay, well, is there an admin page to that web server? Okay, so I need a username and login. Well, how can I find out about username and login? Can I enumerate through that server a bit more to find any more details? And then use Hydra to be able to brute force the password to log in. Essentially, once they've logged in, they can access mechanisms for being able to increment the score in a different way. Okay, so instead of having a lap counter where it's just adding 1 every time, add 10, add 20, add whatever you'd like. And you can also reset the scores. Okay, so you can imagine the frustration that the student, the two teams have when one of them completes the task. They're able to reset the opponent's lap counter, and suddenly they are the winner. Okay, and I mean we were running this workshop around 3 different schools. We ran 4 versions of the workshop, and lots of fun and testing that was happening on campus with us as well. And it was really well received. It was great fun. And I should probably also say, what was really interesting about this is that this actually came from discussions with the NCSE. Actually started out based on the Olympics, because we were working with somebody who essentially had responsibility for the Olympic scoreboard. So that was all internet connected and what have you. But essentially, there was a real world problem that we then replicated through this workshop to make it accessible to kids. But you get the kids playing with scale electrics and they can see this simple example, And then at the end of the day, you say to them, right, okay, so, why have we done this workshop? How could it actually be, something that happens in practice? What are we actually trying to defend against? And you tell them the story about how, the inspiration behind this workshop came from the Olympics when it was held in London. And actually, it was someone's job to defend that scoreboard. It was an internet-enabled device. If the wrong scores had been shown up on there to say, UK won everything or whatever, if it was showing the wrong scores on that scoreboard, that would have actually been, disastrous in terms of our reputation for hosting the event. So it really was, a significant real-world problem that this all came from. And as I say, being able to impress that idea upon the students after the workshop really started to make it hit home. It was really quite interesting. Okay, so I've talked a little bit about our Severo workshop and our Scale Electrics workshop. And, both of these are really nice because, essentially it involves bringing some fun kit into a school, and saying, hey, it's not just a case of let's sit behind the computer and type on a keyboard. There's actual, physical devices here to play around with. And one of the things we've got at UE is the foundry. And as part of that, we've got the Cyber Foundry. And the foundry is all about how do we offer our students a space that is away from our normal teaching labs, has a completely different look and feel. And it's about getting students and industry working together. Okay, so we run paid projects out of there, and we've had students running pen testing projects. So there's a particular company who, ironically, are responsible for video conferencing platforms and communications in that respect. And they've got a product, and they basically said, hey, look, we'd like a student to try and pen test this and actually see what the vulnerabilities are. And so we ran this as a 12-month project with a student basically seeing what they could find out about it. And it's a really nice space because essentially it gives us, as I say, a very different look and feel to our teaching labs. We've ran hackathon events in there. We've got a CTF server, a SOC setup, and it's trying to create different ways of working is what I typically think of it as. We've got a factory simulator. So this little thing down here, which looks like a bunch of Lego, is essentially a factory simulation, which is all ran off of a programmable logic controller, a Siemens Step 7. So the nice thing there is that that's the same controller as what was used on Stuxnet. So you'll probably be aware of Stuxnet. And again, making students think, oh, well, I'm just playing with Lego. And you say, well, actually, you're not just playing with Lego. You're playing with something that is controlled by the same thing that's responsible for uranium enrichment plants. OK, it starts to change the dynamic a little bit. So, as I say, this is our Cyber Foundry. We've got all sorts of different bits and bobs in there. And one of the things we were setting up, late 2019, early 2020, was our IoT workbench. Okay, so we've got a bunch of different devices, from smart kettles, temperature sensors, cameras, doorbells, all sorts of bits and bobs. Okay, so we want to be able to set up this IoT workbench to represent, consumer IoT, what you find around the home and the like. Now, that was all well and good until COVID happened. Okay, so this really nice space for doing exciting, different kind of projects and different kind of teaching. As I say, it was very important that this be seen as something that's different to our normal teaching labs. We've got a lot of labs and a lot of computers in them and all the rest of it, but this was something different. This was meant to be a space where students want to be in there, if I can say that, I guess. This is meant to be a kind of a working environment where students want to be there rather than being told, right, you've got a practical lab at 12 o'clock, attend this session. And COVID-19 put an end to that. unfortunately. We've obviously all had to be working from home. We've had to think about, how do we change up our way of teaching, our way of delivery, and we've had no physical access to campus facilities. Okay, so there's the big red X, no more IoT workbench. Okay, so, and it was a real shame because, as I say, we'd started doing our Scale Electrics project. Okay, and we'd already been to 3 of the schools. We'd run 4 of the sessions with them. We had other schools interested in getting involved in that project. And obviously, I mean, the schools have had it very hard. Obviously, we know that much. And essentially, all of that had to stop. And so the question we had was, well, how do we continue to deliver outreach? How do we kind of continue to deliver these kind of projects, recognizing that there's social distancing restrictions, there's work from home restrictions, all this kind of thing. And I guess more broadly, it makes us think about what are the new ways of working that we need to think about. We've all transitioned to this idea of Microsoft Teams. I mean, a year ago, we had Teams, and very few of my colleagues used it. But now, Teams is second nature. It's what we know, Teams and Zoom and the like. So we've had to transition very quickly to using online video, online teaching like this. So how do we see that, flip it on its head and take that as an advantage? Say, right, okay, I've got Teams, I've got video. What can I do differently there? And a great example, I mean, is the fact that I'm giving this talk now to everyone who is based at Cardiff, and at 12 o'clock I'll be hosting another talk in Bristol, and I haven't had to travel between the two. So there are a lot of advantages that this is bringing in terms of how we can offer our teaching across far and wide. So we don't have physical access to our kit. Students are working at home. So what can we do? So what we're thinking of is hacking the IoT home. Okay, and everyone, we'd done a couple of IoT projects before. So we had a master's project a couple of years back where a student was essentially profiling IoT devices to say, okay, well, can I recognize what that device is based on its network behaviors, and then recognize if it does something that it's not meant to be doing. Okay, so we've done a little bit of work in the past around IoT devices, and that's now who runs our IoT workbench, in fact. So taking that idea further, we're thinking, right, okay, well, everyone's talking about these IoT devices that are in the home that can, how do we make the most of the fact that we're now stuck at our homes? We are told very clearly we should be at home, we can't leave our homes, and all the rest of it. So is there a way we can kind of take that to an advantage? So as I say, we came up with this idea of hacking the IoT home. And essentially what we've got is a CTF style, so capture the flag. Okay, it's a well-known concept, certainly within cybersecurity teaching. There's the likes of Hack the Box and Try Hack Me, Immersive Labs, many others, where students will essentially perform some exercise, and that might be from answering some questions through to actually accessing a virtual machine, trying to gain access to that machine, trying to escalate privilege to gain root access, and essentially obtain some sort of flag, some sort of text that says, yes, this is the code that I now know that proves that I've just done what I was trying to do. So we built this activity based on the CTF style. And then what's really nice about this is that effectively you could then plug it into anything else. If literally all it's running off of is it just needs some text to be entered, you could link that to Cybersecurity 101 from a resource like Try Hack Me. You could link that to privilege escalation, obtaining root access, much more advanced topics, let's say. again, from Try Hack Me or Hack the Box or other resources. And you could do it based on any CTF, which is quite nice. But the key thing that we've got here is that the CTF flags link to IoT device control. Okay, so by being able to enter a flag, you should see some IoT device occur, do something. Okay, and there could be a bunch of different things there. Thinking about the whole gamut of IoT devices that exist nowadays, from light bulbs and switches all the way through to IoT toys, cameras, doorbells, security locks. The list really is endless. There's plenty of things out there. Okay, and the other thing to stress about this is that we wanted to develop this as something that's really quite cheap and affordable. So we've essentially got a CTF IoT server that runs on a Raspberry Pi. It's not very resource intensive, but it means that it's cheap and it means that it's separate. Okay, and that's actually a really important thing, just to be able to say, if you wanted to imagine teachers running this, you could essentially just give them the Raspberry Pi and say, hey, look, that's all set up, it's good to go. It's also quite important because I want to separate that server from the other machines that are running in my house. So actually being able to say, well, look, it's running on a completely separate physical device becomes quite important. Okay, so what have we got then? As we've said, we're essentially running a Raspberry Pi server. So what we've developed, relatively straightforward. It's running Python. It's got Flask installed on it. So it's a Flask server that is able to render a web page that takes in a flag, and it's able to then make a call to an IoT device to trigger a response. Okay, webcams. Okay, I've got lots of cheap ones knocking around here. I mean, this is where we're having to be a little bit resourceful about what we can do based on what's actually available in our homes. And again, it's been quite interesting because we were running this project back in the summer. We had 2 students working on it originally, and it's great because they say, well, I've got one of these devices, I've got one of those devices, and it's like, right, great, let's rig those up then. So we've got a bunch of different IoT devices. The main consideration here is that the IoT devices need to support the 2-year network. Okay, so the 2-year network is essentially a way of developing relatively cheap and straightforward IoT connectivity. Okay, so what a lot of manufacturers will do is essentially build whatever device it is they want, and then say, right, I want it to be linked into 2 years network so that I don't have to deal with that kind of connectivity side of things. Okay, so I think it's is it 6668, something like that, or 6868, I can't remember off the top of my head. But that port number is essentially the port that 2-year devices typically run on. And there's a web page, 2year.com, I believe, where you can basically find out more about this. Okay, so all of the devices I've got run on the 2-year network. And I guess there is thinking about this as a project where we could actually say to school teachers potentially, or whoever it is that may want to run this. We do have to say, well, look, there's a little bit of home networking knowledge required, because you do have to set up port forwarding to your Raspberry Pi to be able to actually allow external access to that web server. So it's a little bit of home networking knowledge, but you'd think that if there's teachers out there who are interested to do this kind of thing, give them a brief guide of how they might be able to do that. They should be able to set it up. Okay, so here's where things get brave. So I'm going to just try a very brief demo. Okay, so here's my little page. Okay, if I just do that, maybe that works a bit better. Okay, so I've got this little page, and this is running live. Okay, and if you want to join, then you're welcome to play along in your browser. Okay, so you can navigate to 80.235.143.15 :9999, and you could actually bring up this web page yourself. Okay, so I'll just give a little moment. I'll sip of coffee to allow people a minute or two if they're going to bring up that web page. Okay. Oh yes, excellent. So I can see some people connecting, which is great. So you know, as I say, it's a Raspberry Pi Flask server. So I can actually see and I can monitor everything on here. So I can see that there are quite a few people connecting to this, which is fantastic to see. So thank you for joining in, for playing along with my game today. Okay, so you've got this page. Now, as I say, enter flag. Now, we haven't really got time to be running any sort of real competition or CTF kind of thing here. But if I just go back here, you might see that there's some flags on that page. Oh. Now this is where my setup gets a little bit complicated. Okay, so I've got some flags on that page. Okay, now what I'm going to do, I'm going to jump over to my hacker house here. So here's my hacker house, right? And I've got, you know, my house here. I've got cameras pointing at different things and the like. And so what happens? So if you were to enter, well, I'll tell you what I'll do. It proves a little bit awkward because I have to start. Right, okay. What I'll do, I'll put it in the chat. I'll put it in the chat and we'll see which one gets triggered first. Okay, so if I type in that one and I type in that one. Okay, so, yep. So have a look in the chat. There's two flags which I've given you. You won't see them on the. Oh, there you go. Someone was very quick there. So someone's just turned it red, and well, let's have someone do the other flag. Anyone else going to do the other flag? Yeah, there it is. It's blue. Okay, fantastic. So straight away, really simple concept. Really simple, I know. But you know, you're sat well in Cardiff or wherever you may be. And you're able to hack my home. You know, you've obtained a flag in some manner. Now, obviously, I've just shown it on a presentation slide here, but you know, imagine if you had a VM or a web page and you were searching through that. You know, you think about OWASP Juice Shop, for instance. You know, it's a fantastic resource. It's got loads of flags built in already. Runs as a web server. You can do all sorts on there. So the real point about this was that I wasn't necessarily trying to say, well, let's create a CTF from scratch, because there's plenty of them about. You know, we know this. But what this gives us is just a way of being able to make it so that flags come to life a little bit. You know, rather than saying, oh yeah, I've been able to, you know, type this flag in and it says correct. Well, that's all well and good, but you know, can we do a little bit more? So I can see lots of people are still typing things in, and this is where I bet someone's going to try and break it now, try and do some sort of injection attack on us or something. Anyway, let's hope that that doesn't happen. So I will, if I flick to, well, I'll tell you what, no, I'll type it in the chat again, because I think that's the easiest way of doing it, rather than jumping back and forth on there. So if I type in another flag, I'll see if anyone wants to submit that one. Oh, yep. So there we are. So appreciate on a video, it might not be rendering that well, but that fan is blowing. Yep, that's nice. And you've stopped the fans as well. Yep, that was a good guess. I haven't told you about the flag yet. Okay, so start the fans, stop the fans. Kind of implies what's going to happen, but nevertheless, that's all right. And then the last one. Okay, well, in fact, I will actually switch back here. So we've got the fan blowing, and that's nice. I've got a nice breeze coming through, and there's start the fans hidden in some light grey text on there. Okay, so here's another one. Now, we may, in the interest of time, we may not stick on this too long, but here's the idea of a challenge card. Okay, and it's again really simple concept. this is essentially just, what a CTF challenge could look like. So here's some numbers. Essentially, it's a bit of ASCII text conversion. So what kind of flag might that be? Okay. Someone's trying UE ABC. Okay. So I'll save us the effort of having to try that. So this one, if I type it in here, are you seeing? Yeah, you are seeing that. So I'll jump back for a minute. I'll type in this flag here. Okay, I'll submit that. Oh, and there we are. Okay. So RoboGo was the flag. Okay, RoboGo, and sure enough, my Hoover has just come into view. Okay, so that was waiting out of shot, and the big reveal is that the Hoover comes into shot. And again, you can have lots of fun moving the Hoover around. So RoboGo, and I believe it's is it spin? So I can't remember the other flag now. So no. Oh, someone set it off. Let me just do the other one very quickly. So anyone going to submit that last one? Hopefully that'll work. Yeah, sure enough, might be a bit hard to see on the video, but you've now sent my Hoover spinning around in circles. Okay, and it's going to keep doing that, and it's going to keep doing that. Okay. There we are. Right. So we'll keep going round. Hopefully that's not too bad on the noise for you all. Okay, so that you can have the students doing the hoovering for you. Absolutely. That was my intention all along. Okay, so if I jump back to the slides then. So we hosted a small pilot study of this online back in summer 2020. The initial response from students, it was cool to control things remotely and to see things happening in someone else's home. And I think, it's a really important point to emphasize that, and hopefully you've experienced a little bit of this yourself. The idea that you've just been flicking the light switch on and off in my office, you've been able to turn the fans on and off, and you've actually been able to control something that has physical movement and can wander around the scene. So it's and being able to do that remotely, it does bring a different sense compared to if you are in the room with that same device. If you're in the room with the same device, there's kind of no magic to it. You say, well, of course I can control it, it's right next to me. But being able to do that remotely, there is something slightly different there. And I think that was a really key point to get the students to think about, that such a big part of cybersecurity is obviously about how someone can attack some other system despite the fact that they're not next to each other. So this is all about turning work from home into an advantage. We have IoT devices around at home, and obviously, as I've said, we have IoT devices at work. We just can't go there. But if we're trying to set up a study around hacking the home IoT network, well, I'm in a home. I don't mind giving up my home for this purpose, for the workshop and everything. But we can set it up so that we can actually get a sense of hacking a real home kind of thing. So it increases online engagement for students. It's a different kind of session. May encourage it further exploration. Yeah, I'll get onto the questions shortly. So yeah, and I think the really important thing to impress upon here is that, of course, we say hacking an IoT home. Well, yeah, okay. It is a nice controlled demo. It's not set up for actual hacking, if you like. Much in the same way that vulnerable boxes on Try Hack Me and Hack the Box are, purpose built, aren't they? But the key point really is, if a student sees this and a student sees, they're able to control a robot wandering off around my house, does that inspire them to then say, well, what else could I do? And delve into that subject more, because I think that's one of the big things about outreach, is that we do a lot, particularly with year 8 students in our taster days, for instance. But then it's the kind of, well, what happens next? How do we make sure that that interest is continued rather than it being just for a single day? So just thinking then about how remote working and COVID has changed the way we think about cybersecurity education. Yes, we know that we're at the start of this roadmap coming out of lockdown and the like, but kind of like I was saying at the beginning of the call with a couple of people, it really has been an opportunity to think differently about how we do our teaching. The idea of running standard lectures where a lecturer will literally just talk and talk and talk, that is now a thing of the past. We can make a video of that. That can be watched in someone's own time. That makes it so much more accessible, whether they're watching it at home, in bed, on the bus, wherever, And so having lectures as videos, makes a big difference in terms of how we fit all of this in. But then it's how do we think about doing practicals differently? And, if we're thinking about physical kit, well, we can still use physical kit even when we're not physically located. And as I say, I think one of the big things about this is that we almost should be doing that for cybersecurity education, because hacking into a box which is sat on the table with me, well, I've got physical access. I kind of don't need to take the techie route if I've got physical access to something. So by removing physical access, you're actually illustrating the point much more effectively that the role that cybersecurity plays in being able to have remote access to devices, such that I can be here or you can be in Cardiff controlling devices that I've got set up in Cheltenham. So you really are able to get that appreciation of distance and physicality kind of doesn't matter anymore when we're all connected. So I think the key point is about remote access of systems. How do we keep that remote aspect in the future? It would be a shame to think that we basically come out of lockdown, we return to campuses, and we treat practicals in the same way that we've always done beforehand. I think with Teams and the like becoming much more widely used, I think there is an opportunity here of how do we make better use of remote access for this kind of teaching. And just one final thing to touch on then, one of the things another project we're working on currently is around cyber-physical systems security, looking at industrial control systems and factory simulations. So we've got a factory IO virtual simulation. Okay, this virtual simulation can be observed remotely, so students can log in and say, oh yeah, the factory is running as it should be. And it's controlled by a PLC device, a programmable logic controller. So that can actually run on a Raspberry Pi, yet again. So all of our MSc students get a Raspberry Pi and a microbit as 2 devices that they use throughout the course. So using a Raspberry Pi, if you've got OpenPLC running on there, you could actually write the program logic and control that simulation from the comfort of your own home. And then you can think about, okay, if I've got my PLC running here and it's controlling the thing over there, intercept that traffic, being able to then inject or spoof activity across that network. But again, this doesn't require being physically located next to the system that's running the simulation. This can all be done remotely. So we are actually at the start of a CyBOC funded project on this, looking at cyber-physical system security, because we've got a module, critical system security on the MSc, that we are essentially aligning to the CyBOC. Okay, we've been teaching it for 2-3 years now, but we want to make sure that what's in the CyBOC is covered in there. And we're actually producing community resources using the factory simulation, using OpenPLC, but people will be able to actually, download this, get, run through the workshop of getting that set up and attacking it. So I can see there are a couple of questions, so I'm going to jump onto those. My takeaways really, cybersecurity is at the heart of remote learning and teaching. So how do we emphasize this? Can online meeting platforms be used for better educational experiences compared to how we've done things traditionally? And work from home has really allowed us to try and innovate our teaching in different ways, try new ways of working. So I really hope that as a community, we continue to kind of foster that and think about how we use this for the better. As technologists, certainly in the area of cybersecurity, this is the kind of thing we should be thinking of. So it'd be a real shame to just return to campus and go back to normal, if that makes sense. We should be thinking about, what new things can we do? So with that said, thank you very much for listening. It's been an absolute pleasure, and I'm happy to take questions.